Okay, so this portion of the unit deals with solving equations, and when you solve an equation, what you're doing is finding or solving for x or theta or whatever it is. So when you look at this example, is you look at what the cos of this angle equals this half of the equation. So then what you would do is use your special triangle, and you use the one that's pi over 6 and pi over 3 to get the root 3, the 2, and the 1. So then you think cos is adjacent over hypotenuse, so then you think it has to be adjacent, so what equals root 3 over 2? It can't be, because this would be opposite, so then you use pi over 6, so theta equals pi over 6, and then because it is positive, you have to consider more than one rotation, so then you use the cast rule, and you say that this one's in quadrant 1, so then it's always positive, and then you would also consider an answer in quadrant 4, so then your other answer would be 5 pi over 6, and then you just include a final therefore statement with pi over 6 and 5 pi over 6. And that's your answer. Okay, so this is our second example, and it's pretty much the same as the first example, except for this one you just use a little bit more algebra. So to do this, first what you want to do is cancel out, get rid of this squared. So in order to do that, you take the square root of it. And when you do that, you have to also take the square root of the other side. But then you can't forget that you have to take the plus or minus of that one side. So then this cancels out the squared, and then you're left with tan theta is equal to plus or minus 1, because the square root of 1 is 1. And then once you get to here, you would just do the same method as before, and you use your special triangle. So then you have your pi over 4 on each side, and it's 1 and root 2. So then once you go there, you think tan, so that's opposite over adjacent, and then that would give you, it doesn't matter which one, so it would be pi over 4. And then because it's plus or minus, it would be in all quadrants, because in all quadrants they would be positive, so then you just do your answer in all quadrants, so 3 pi over 4, 5 pi over 4, and 7 pi over 4, and that's your answer. Okay, so what can also happen is if it doesn't fit into an exact triangle or into your unit circle, then what you would do is you would take this and you would use your calculator and to take the inverse of it and make sure that your calculator's in radians, and then you would just solve it the way you would solve the radians and find the quadrant it's in the same way, but just using a decimal with radians. Okay, so this is our third example, and it's a little bit more challenging than all the other ones because you have to use identities. So when you go through, you start with your Pythagorean identity. So you use sine squared x is minus 1 is equal to, and then you would change your cos squared x into 1 minus sine squared x, and then you would move everything to one side so that it's equal to a number, and then so you get 2 sine squared x minus 2, because when you move it over, and then it's equal to 0, and then what you would do is you would factor to get that, and then this is a difference of squares, so then you would continue to factor it again to get sine x plus 1 and then sine x minus 1, which is equal to 0, and then you would bring this down to have it equal to sine x plus 1 is equal to 0, and then the other side, sine x minus 1 is equal to 0, and then you would just solve like you would normally solve, so bring the 1 over to the other side. So sine x is equal to -1, and then sine x is equal to 1. So if you use the unit circle, what you're going to do is sine x is equal to y over r, and r is 1 in the unit circle, so it's just the coordinate of y. So when y is -1, you are down here, so then that is 3 pi over 2, so x is equal to 3 pi over 2, and then you do the same thing for this. So when the y coordinate is 1 is up here, and that's pi over 2, so x is equal to pi over 2. And then you have to take into account the domain of what you're looking for. So it has to be within pi to 2 pi, so it has to be in this half. So then pi over 2 would not count because it's not in the domain. So then your final answer is x equals 3 pi over 2.
So this is the final section of this video and of this unit. I have one question prepared for you, and it is a business application question involving equations. So the question is, a model for the revenue of a company is modeled by that equation, where R is the revenue measured in dollars and T is the time in seconds. In the first second, when was the revenue $2? Okay, so for this question, we are doing when the revenue is $2 in the first second. So our period is 2 pi over 4 pi, which equals 1/2. And this is, so half a second, 0.5 seconds. And we want the revenue in the first second, so we need to consider 2 cycles. So to start off the question, we're gonna plug in the $2 for the revenue in the equation. So then we want to get rid of this 4, so we're going to divide by 4 on both sides. So the 4's cancel out, and then the 2 over 4 reduces to 1/2. So then we get 1/2 equals sine squared 4 pi t. So then we want to cancel out the squared, so we're going to take the square root of both sides. So then we're going to get square root of 1/2, and don't forget the plus or minus, equals sine 4 pi t. So then the 4 pi t becomes our theta. So then we're going to have 4 pi t equals, and that's the theta. So then we must, for our answer, we must consider all 4 quadrants. So then we get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then we also have to add 2 pi to each of them. So then we get 9 pi over 4, 11 pi over 4, 13 pi over 4, and 15 pi over 4. So then to get it into seconds, we have to divide all of these answers by 4 pi. So then we get 1 over 16, 3 over 16, 5 over 16, 7 over 16, 9 over 16, 11 over 16, 13 over 16, and 15 over 16, and those are all in seconds. So then for our therefore statement at the end, we write therefore the revenue is $2 at 1 over 16, 3 over 16, 5 over 16, 7 over 16, 9 over 16, 11 over 16, and 13 over 16, also 15 over 16, and this is in seconds. So that's our final answer for this question.